So problem 2 is writing a system as a matrix equation. So the key word here is write. Okay? Like if I said write your name, you would write, your name, Mr. Parks. So the word write is a very simple word. Write each system. Okay? A system is when you have more than one equation. You may recall from Algebra 1 that 5x minus 4y equals 4 is in line, 3x minus 2y equals 3 is in line, and in order to have a solution, you're looking for where they cross. So where do those two lines cross at? Okay? And you may remember that in Algebra 1, you solved this using elimination or substitution. Instead of showing you that way, I'm going to show you how to solve it using matrices. Okay, so we're going to write each system as a matrix equation. So, let's keep in mind that the first column should be the x, the second column should be the y. Okay, so first you need to make sure it's in standard form. Is it x, y equals constant? Yes. Now you may see down here, it's not x, y equals constant, so you have to move stuff around. Okay, so we're going to put 5 and 3, negative 4, negative 2. Okay. And what this is called, is it also says identify the coefficient matrix, the variable matrix, and the constant matrix. This is called a coefficient matrix. Coefficient matrix. Remember, coefficient are the numbers that are in front of the variable. So coefficient would be the numbers in front, right? Second, you're going to make the variable matrix. And our variables are x and y. So this is called a variable matrix. And then equals the numbers by itself. Those are called constant matrix. So let's just make sure we answered the question. They said write each system as a matrix equation. We have a matrix with an equation, so we did that. And then also said identify the coefficient matrix, the variable matrix, and the constant matrix. Notice nowhere does it say to solve. Okay, that'll be the next skill. So for now, can you take a system of equations, write it as a matrix equation, and then identify the parts? Okay. That is it. It does not say solve. B. B, is this x, y equals constant? It's not. Right? Right, so I need to move the 8y over here. Remember when you move things to the other side, they change sign? And I need to move the 3 over here. So that would become 2x. When I move this over here, it becomes minus 8y. When I bring the 3 over, it becomes negative 3. Okay? Because you subtract 8y from both sides, you subtract 3 from both sides. Now here, it's almost in the right order, but it needs to be x then y. So you're going to put negative x plus y. So in other words, put it in standard form. Okay? And then write your matrix. So help me out. What would be the first matrix? 2, negative 1. What else? 8, 1, right? And what do I call this matrix? The coefficient matrix. You have to put that, okay? You have to, because it says identify. Okay? And then what would my variables be? X and Y. And that's called my variable matrix. And then -3, -4 is my constant matrix. For now. Now, before we move on, it's important to talk about why does this work. Remember, when you multiply two matrices, the number of columns here have to equal number of rows, right? And you take row times column. So if you think about it, if I cover up this row, it's 2 times x plus 8 times y equals -3. That's this one, right? Oops. Oh, you know what I just noticed? We forgot a negative here, didn't we? You guys didn't catch that. So I shouldn't even look at this one. I should look at this one. So 2 times x minus 8 times y equals -3. And then on the second one, -1 times x plus 1 times y equals -4, which is this one. Okay. And so when you set this up as a matrix equation, then you could solve for x, y by finding the inverse. And I already taught you how to find the inverse. So a 3x3 is just the same. It's just a little bit longer and wider. So go ahead and see if you could write this as a matrix equation, and then identify the coefficient matrix, the variable matrix, and the constant matrix.